So, what is RNN? RNN is a powerful type of neural network which has memory and remembering capability. So, they are able to remember things about the input they receive and make them precise in predicting what is next. So, let us look at a standard RNN, the way it looks at any point of time. You actually have a loop within a node of t steps. So when I say a node for t steps, you look at the figure here, which I'm talking about, where I'm creating a neural network which is recurrent. There is usually a loop here, just like here ht, which says that at this node A, there are t cycles in this particular loop. So you need to understand that since we're talking about a cycle in a particular node of t cycles, the usual semantics of such a recurrent network is that the network is unfolded t times, and the way this unrolled neuron looks like is as if there are t different neurons connected to each other. The unfolded will be very similar to what you have in a multi-layer perceptron or a conventional, neural network, which is feed forward. But the way semantics works is, if you look at the in the t cycles, if you take, let's say, one of the intermediate cycles ht, and you want to find out the output at the node ht in terms of the input provided to it at xt, it's not purely a relation between xt and ht like it would be in a feed forward network. Instead, there is a dependence on, the ht minus 1, and the way it would go is, if there is a dependence on the previous node, which is t minus 1, then ht will be determining ht plus 1, and so on. So this kind of a cycle unfolding helps in giving the semantics to the recurrent neural networks, where you have nodes which have cycles in them. So if you see the expanded network, which is shown here, goes by the semantics which is given here. So if you want to understand where this is useful in all the kind of scenarios where it is going to be effectively remembering the past to determine a future value. So recurrent neural networks are therefore very useful for sequential data, where previous data output is used to predict the next one. And loops within the hidden neuron gives them the capability to store information about the previous words for some time to be able to predict the output. And the output of the hidden layer is sent to the hidden layer for t timestamps, like we saw in the unfolded neuron. So output of recurrent neural network goes to the next layer only after completing all the t unfolded timestamps. So you can imagine that the output sent here is more generalized, and the previous information is retained for a longer term as compared to what you do in a conventional feed forward network. So you need to be very clear that in case you're talking about a scenario where there is a lot of application of past data to predict the newer data. It is usually taking the path of circular nodes and semantics being enforced by what is known as the unfolding in form of T different nodes. So now the question comes, in conventional multi-layer perceptron, we are all very used to seeing the conventional, what we call as, the back propagation as a semantics for updating the weights. So once the forward loop happens, where sigma wi xi of each input node for a layer, a node at a certain specific layer is computed and passed on to the activation function. Then you compute the output, then kick it on all the way to the end output node and see the delta, which is the error between expected value of output and the actual output you got as the end result of the feed forward activation loop. Then you work towards taking the difference, which is delta, which is back propagated through the different hidden layers all the way to the input layer, and the weights are updated.